Today on FlyWire we're going to talk about accidental safety, and we're going to look at one particular accident. It's J35. It's not actually this picture, but it's to outline the real topic is how the fine art of learning from others' experience. Okay, so that's what we're going to do is we're going to learn from this J35 accident, so stick with us on FlyWire. Hey, I'm Scott Perdue, and today on FlyWire we're going to use a J35 spin accident to talk about how do we mitigate risk. Basically, flying is a bit of a risky thing, so how do we best mitigate that? Of course, you know, I'm an advocate of training and regular practice, and in this situation, that regular practice thing might have gone awry. So this is actually part one of a two-part series that I'm going to do to cover the topic that I gave to the Bonanza Society convention a couple of weeks ago in September of 2022. I had two topics, or two accidents that I talked in within the topic. Way too long to do a video for YouTube, so I'm going to redo this as this. And both accidents I'm going to talk about are from the hit list of categories that kill us. Loss of control in flight, control flight and terrain, unintentional flight to IMC. The big two here, we're going to talk about those. This is in part two, this is part one. Part one is a deeper review. This J35 accident I actually talked about already as a quick look, and it's this airplane. It's 8255 Delta in Helena, Montana in 2013. So this is the accident site here. Here's Helena, Montana, where he took off from, the pilot took off from. And this is the accident site just north of there. The weather was good, calm winds, clear skies, temperature 20, dew point 7, 2965 on the altimeter. It was a pretty day, and he went out to go flying. So let's see what happens next. This is the accident site here, a closer look at it. This is from the final report, by the way. They had 3 witnesses in total, 2 of them that saw the airplane or heard the airplane. And they were both pretty close to each other along this residential road, witness 1 and witness 2, just about 0.8 of a mile from the accident site. Witness 1 observed the airplane, and according to his statement, he saw it do 5 slow spins before it disappeared from his line of sight. And then the impact happened. He didn't actually see the impact, but I believe heard it. Witness 2, on the other hand, didn't see the airplane, but he was alerted to the problem maybe he did see it for a very short amount of time, but he heard it. He said the engine struggled twice, okay? And that's kind of important. We're going to talk about that a little bit more in a second. There was a third witness down here that chimed in and offered his observation. He's 8 miles from the accident scene, and by the way, the accident was 8.5 miles north of the airport, and witness number 3 was 1.5 miles from the airport right here. So what happened in this case, or what this witness 3 reported, is he said that he thought that the accident airplane had a near midair with a Cessna 182, and that's what he saw from his perspective. The tower controller watched the takeoff, and he saw the whole thing, and he was controlling another airplane in the pattern. It was a Cessna 172 who was doing practice patterns for this runway here, and he said there was no conflict. He didn't see any conflict at all. So what witness 3 saw was a perspective issue. He said it looked like a 182, but it was a 172. Size-wise, it's not a lot of difference, but it was a high-wing airplane. And the perspective that he saw was airplanes like this, lined up. So here's an interesting thing about accidents and accident investigation, and I'm going to talk a little bit more about that here in a second. So witness input is very important to trying to figure out what happened in the accident. But you got to take it with a grain of salt, because if the witness is not a pilot, then their observation is a little bit skewed. In other words, I would lend more credence to a pilot's observation just because he's used to the environment and what airplanes do, and versus somebody who's just a witness, like witness number 3, who's not a pilot and he just saw these airplanes. Okay, so his input is, well, we got to listen to it and we got to evaluate it, but it actually doesn't have much relevance on the accident itself. But witness 1 and 2 has a lot of relevance. Okay, so we're going to talk about that here for a second. So right away, we know from witness 1 that the airplane was indeed spinning. That was his testimony. It was going around and around, did 5 slow turns. 5 slow turns. What does that tell us about the accident? Well, it tells us something pretty important in that it was spinning. It confirms that, and we're going to see some more evidence of that in a minute. But what it tells us is that it was sort of an abnormal spin. Okay, in other words, it wasn't a normal spin, which has got a fairly rapid apparent yaw rate. So witness number 2's testimony that he heard the engine struggle twice. Okay, so that's important because what that really tells us is that the engine was at high RPM, and we know that because so you've been in air shows and you've seen the extras and the edges doing their thing and doing spins or whatnot, and what you hear as it wah, you hear that prop noise, that wah 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 noise going, and what that is the prop plane going by your observation position. In other words, you see that rotating plane of noise coming off the prop as it goes right by you and coming back around in the circle. So that's what you're hearing. That's what witness number 2 heard. And that tells us that the engine was very likely at high RPM. So as we do an accident, I think there's a little bit of misunderstanding about what an accident investigation is and how it proceeds. Okay, there's no real magic per se in it. What it is a lot of hard work and experience to try to figure out what happened. Okay, so the actual physical examination of this particular accident revealed the throttle mixture and prop controls were firewalled. Okay, on the accident, and the impact angle could be seen to be very steep with little forward velocity, and it hit left wing low. Okay, so when you're doing an accident investigation, you generate as much facts as you can. The witness inputs are important here, witness 1 and 2, how this accident presents itself, what the wreckage presents to us. We glean factual data from that, and then we construct a theory on how that happened. In other words, this theory has to account for all these facts. And if we come up with another fact that basically blows that theory out of the water, well, you throw it away and you develop a new theory to meet the facts. And that's how you do accident investigation. So you do speculate, but you do it based on factual evidence completely. And that's how an accident investigation progresses. That's how you can glean information out of it. So I'm going to go through this particular wreckage and we'll talk about it. So this is the airplane. It's upright. This is the left wing. It hit left wing low, so left wing impact first here, and you can see a lot of damage and torque. So you can see a lot of wrinkling to where the tip hit and then kept going. In other words, there was some angle to the bank before the nose hit, and you can see this wrinkling in the wing here that tells us that it was twisting. It was indeed rotating. The other things that we can tell from rotation here is that when the nose hit, this is the engine right here. You can see that it's slightly off cue. So it didn't hit nose straight in, it hit nose and turning because the engine stopped turning faster than the rest of the airplane did and basically ripped off of the firewall as it stopped. The ground made the engine stop, but the airplane fuselage kept rotating. Okay, that's another thing that we can see here. And then we can see this wrinkling here at the retrovators, and then right here just after the baggage compartment. And this is the gap. It's about right around 2-ish feet, something like that, where the normal gap on this airplane, I can measure it, but I think it's well over 8 feet. So there's a big difference between what normal is and what this accident presents us. The other thing we can see here is the cowling. This is the front part of the airplane, nose part of the airplane, and then this is the top part of the fuselage and where the windscreen is. The seats are right here. You can see those. So we know that this airplane was doing significant rotation, and when it on impact, and it had a fairly steep nose angle. It didn't go very far, and it didn't flip over, so it had very little forward velocity. So let's take a look at this wing. This is the right wing, and if my theory based on the facts that I know from this side over here is true, then we're going to see very little damage to this wing, and that's what we see. Okay, there is damage here. This is where real close to the nose area, there is damage on this side, but it's more tearing kind of damage, and you can see the forward spar right there. This is the leading edge, and there's very little impact damage on the leading edge. This is the wing skin that is riveted to the forward spar. It's just after the forward spar, and it's got a rivet line there. And one of the things I've seen quite a lot in accidents, bonanza accidents with this wing, is if it's not a straight in impact, if it's got one wing first and the wing's low, you get a lot of torque twisting moment, and that's what this is it basically zippers off all those rivets from that aft wing skin from the forward spar, and that's what you see right here. Is this whole thing is zippered off, and so that tells me there was a lot of torque. Again, that confirms that this was a lot of rotation in the accident, the impact, and it was very steep. And this is the rudder vader, and as the whole fuselage, look at this, the whole fuselage will continue to rotate, like the engine stopped first, and then the cabin stopped, and then this continued to rotate, and that's what we see, this bending moments here and here, and it's a bit twisted off to the left. So that's another confirmation that it was in a left spin. And that's the damage there. Here we can see parts of the engine, etc. So this is what the FAA came up with for a probable cause. They said the pilot's failure to maintain adequate airspeed while maneuvering, which resulted in a aerodynamic stall spin and subsequent impact with terrain. Okay? And I would say, yeah, this part of it is really obvious, resulted in aerodynamic stall spin and subsequent impact with the terrain. This failure to maintain adequate airspeed while maneuvering, I think that is pure speculation. There was no analysis here to determine how did this pilot get into this situation where he stalled and spun the airplane with full power. There was none of that. Okay, how did it happen with inadequate airspeed while maneuvering? What maneuvering was he doing? There's no analysis here to tell us that. So for me, this is not a very worthwhile probable cause. It doesn't actually tell me anything that's useful. I'm not sure it actually would tell the insurance companies, would they care about this? I don't know. I'm not going to speculate about that. But for me as a pilot and as an instructor, and I think it's important that when we look at these accidents that we find out basically how the probable cause of how the pilot got into this accident, how it progressed, and then how we can avoid that accident in the future, because I think all of these accidents, at least the ones I review, are ones that could happen to each and every one of us. If we're not careful, if we're not observant, or we're unaware of the issues that are addressed there that resulted in this accident, this could happen to us too. So with that in mind, I'm going to talk what I think my speculation here is I went through a bunch of different scenarios as how he could depart the airplane with full power, okay? And I think he did it before the departure. Actually, I think it was a power on stall. So what's a standard power on stall setup? About 20 inches of manifold pressure, maybe a 20 degrees-ish nose high with full RPM or high cruise RPM setting. And then you hit the buffet, and then you basically recover the airplane. It's an unload, etc. So that's kind of the recovery procedure. So he had a high-density altitude. Maybe he was about 8,000-ish feet or so when he started this power on stall. My speculation that it was a power on stall. But I can't see how you could be stalling the airplane, departing it with power in either. But he did have high power setting set. So that's the setup. That's what I want to talk about. And what I'm going to do here is the thing about power. I'm not a big fan of power on stalls. I just find it the epitome of situational awareness, the loss of, if you're doing a takeoff with full power and you pitch up to the point where you're going to stall. I think it'd be more likely it might be an accelerated stall on a turn when you're trying to turn too much, trying to pull too much G in the turn, and you exceed the critical angle of attack. Your wing quits flying, and off you go. I think that's more likely than a power on stall. The thing about a power on stall is, if you have full power, that's a pro spin input, okay? And that is a problem, because if you're at this pitch angle, about 20-ish degrees, you stall the airplane, your yaw is going to happen right quick, whether you do it or not, you initiate it on purpose or not, the airplane's going to fall off on a wing, you're going to get yaw almost immediately. So what do we need to stall? To spin, we need two things. We need stall, and then we need yaw. We can go fly the airplane and fly it along, and we can press full rudder and yaw the airplane with as much authority as we have, and it won't spin. Conversely, if I stall the airplane, I can hold it in a full stall with full aft stick and use the rudder to keep it from dropping off on a wing and any yaw developing, and that's called a falling leaf maneuver, by the way, and it won't spin. So you need those things in that order. You need to stall and then yaw. So how did we get this? Well, years ago I had an extra 300L, and I bought it to do a upset prevention and recovery training, and I call it the AMT, so fly AMT. What I did was I went up and I videotaped accelerated spins. We did a normal. I did. This is all. What are the various control inputs that we can make and what do they result in a spin? What happens in the spin when you do that? So we do a normal upright spin just as a baseline to see that, and then we do a in-spin aileron, and then we do an outspin aileron. We do outspin aileron with forward pitch, and then we add power. So outspin aileron, forward pitch, and power to see what happens here. Remember, these are all mostly pro-spin inputs when we do this. And remember that when you're flying an airplane, just put yourself in perspective. When you're flying an airplane, you have relative wind, boundary layers attached, all that stuff the airplane's flying in normally. That's one thing. All these flight controls have a different effect when you're not flying normally. When you have the relative wind approaching the airplane in this direction, they all do something different. Okay, your CG is no longer the airplane doesn't react to your CG like it did before. It reacts with mass moments that you have out. The engine is one, fuel in the wings, tip tanks, etc. Wing engines on the wings, all those things affect the mass moments. So the spin behavior is different, and it's also dependent on the wing. So what we're going to see here is in the extra, we're going to try each one of these different things. The first thing is a normal spin. This is upright to the left. I did all of them to the left just to be consistent so we can compare it. We see the brake, heavy-duty slice, almost inverted, and then it sets up in a nice, fairly stable spin, fairly nose low. I want to say in the 70 degrees range, and that's where I think the J35 accident happened, somewhere in that range. Okay. This one here is in-spin aileron. The thing about in-spin aileron, you're going to watch this, it's going to look like the increased yaw rate. In actuality, in-spin aileron is anti-spin, it's pro-roll. And you're actually rolling into the turn faster, but you perceive it, you see it as yaw. Okay, now this next one is going to be outspin aileron, and it's going to be oscillating and pitch and increased yaw rate. So let's watch that. Set up the spin, and then deliberately put in outspin aileron. Nice slice again. Spins developed, outspin aileron. You see that? Increased yaw rate and oscillation. We see the sky up and down. So I'd say that's probably 20 degrees or so of pitch oscillation. So the next one here is forward stick, and this time we're going to see a higher nose attitude, oscillating pitch. This is approaching a flat spin. Forward stick is a pro spin input. See this? It's more stable, not oscillating as much, it's more stable, and the yaw rate is faster. Forward stick, I'm stomping my foot here, forward stick is a pro spin input. Okay, now let's do one more, and let's look and see what happens when you use power. Okay? There we go. Set it up. Now, you see this? There's very little oscillation. There's still a little bit, of course, but there's very little oscillation compared to before, and it's a much higher yaw rate. This is a flat spin. This is what you see in air shows when people are doing flat spins. And the thing about a flat spin is power is a pro spin input. It's all the gyroscopic forces and the influences on the spinning airplane, and it results in a pro spin, pro yaw input. Okay, that's what's going on. So in the J35 accident, then what happened was he had full power on, pro spin, and then when the stall happened, I would be willing to bet that probably him and 95-98% of y'all watching this right now would think, well, the number one thing I want to do is I want to unload the wing. I want to push. And so here he is, stalling, probably yawing, full power, and he pushes. So he's starting the spin because he has stall and then yaw, and he's got pro spin input of full power, and pushing forward stick is pro spin, so now he's in a flat spin. And I'll tell you that most flat spins in just about every airplane I can imagine, especially with power, is unrecoverable. You're not going to be able to recover a spin from without reducing power. And that is such, it overpowers the whatever rudder action you can take. Okay, so that's what I believe happened is he had in a flat spin and it was unrecoverable. He never changed the power. So this leads me to, let's talk a little bit about wings and aerodynamics. In my aerobatic bonanza here, I call it Charlie, I tufted the wing, one wing, and then I did inside and outside. So I did right and left spin so I could see what happens to the wing on the inside and the outside of the turn. It's real important to notice the flow pattern, and I think I'm going to do a whole maybe one or two videos about the wedge because there's some really cool stuff happening there. I'm not going to spend much time on it in this video. Most importantly, I want you to watch what happens to the outside wing when I get to that point. So this is the wing and it's tufted. The first one is going to be an inside. This is the wedge that I'm talking about, and pay attention to what's happening at that yarn there and the yarn pattern going back here. Okay, so here we go. You're going to see the break happen here. AOA break happens here first, then here, and spreads across the wing except for the very outside tip. That's the fully developed spin, and then the recovery, boom, and we're flying. This is now the outside wing, okay? And the FAA says that this is the outside wing is less stalled than the inside wing. It's stalled, then fully developed, bam, the whole wing is flying. This wing is flying. It's not less stalled, it's flying. So here's the important thing about what's happening with this wing, okay? The wing is this flying wing is now creating an auto-rotational moment. So in other words, all that lift on the outside wing and the inside wing being stalled wants to roll and yaw the airplane into the spin. This is what keeps the airplane in the spin. Now if you add power or forward stick, outspin aileron, then the airplane, those are all accelerated spins. They all accelerate the spin, and you're going to stay in the spin. If you have power, you're not going to get out of it. So here's the next thing I want to look at is we can see this during the spin. This is recorded during the right spin. So you can watch and see what happens to this actually goes to a G meter. And you can see how much altitude I lose and what the airspeeds are here. So let's watch this. You can see the brake and the unhook. It wants to go left. That's the brake. It wants to go left, but it goes right because I'm using right rudder to initiate the spin. And there's the spin, the one we just saw, and the recovery. So boom, nose above the horizon at 5,100 feet. It started at 6,600, so that's 1,500 foot altitude loss. But you notice the speeds. Yeah, we saw the speeds. It was not where you think it might be being stalled. Okay, so you are getting airflow across that the probe, but you're not. It's not actually doing you any good as far as lift across the wing. So that's, I think, a fascinating video. So what is? Here's the thing about a power on stall. Was pushing the correct reaction to the stall in that case? And what I'm saying is I don't think it was. Because he had full power, stall and yaw, and he pushes, he's going to jump right into a flat spin right away. And as what I just said is that's unrecoverable. So the only way he could recover from that situation, that flat spin, is to use a little different than PARE, P-A-R-E. I'm not a big fan of mnemonics because it doesn't actually cover the full range of the issues that you might face. In his situation, if he'd done PARE, it wouldn't have worked, because he had power. He might have let the pitch float. He should be, because at least coming back on it, because that's what PARE has in it, but it doesn't have the most important part for what was happening to him. In my opinion, he needs to go idle, neutral, aft. Okay, idle power, that's the pro spin input. You got to get that out of there. Neutral on the ailerons, and then aft on the elevator. That does a couple of things. I didn't invent this. It came from the Air Force training that I went through. So idle, neutral, aft. When you go aft on the elevator, it does a couple of things for you. One is it stabilizes the spin and allows as much relative wind to be exposed to the rudder as possible. So then the next step is actually to use rudder to stop the yaw. And that's how you recover from the spin, followed almost immediately. Not quite simultaneously, but very, very close, where you go forward stick to break the AOA. So we stabilize the spin, and then we're going to stop the yaw. All right. If you're upside down, that's the second benefit of this idle, neutral, aft, is if you're upside down in the spin and you go idle, neutral, aft, the airplane will fall out of the inverted spin into an upright spin, and you're not in opposite world anymore. You can recover the airplane. Okay. So it's really good to do actions. In my view, I like actions rather than mnemonics. So this situation, how we don't really need to plan or shouldn't plan for a spin recovery out of a power on stall practice. So what happens here? How do we recover from a botched maneuver? And when I teach aerobatics, one of the things I teach is basically how to do this, how to recover from an extreme unusual attitude in a botched maneuver, and or a self-induced extreme unusual attitude. What I'm going to show you here is a video I made a while back. I was trying to do 3G loops in this Bonanza, and I didn't publish it. It was up for my Patreon supporters to see, but I didn't publish it on YouTube. We're going to see it here today, and what happened to me in this situation is actually very close to what happened to that J35. Not exactly, but I'm about here in the loop when I run out of energy, and you'll see it as you watch the instrument panel over here on the left side. You can watch the airspeed indicator, and it's going to about 0. So I'm about here when the airplane hangs up. I don't have any more energy. I can't influence anything. Basically, I'm going ballistic. But I have full power, okay? That's the similarity. 0 airspeed, full power. I didn't stall the airplane, okay? This is the interesting thing. So what my reaction is I neutralized everything. I didn't change the power, because I hadn't lost control of the power, and I actually didn't want to mess with the engine when it was here like this and just let it run and not try to change RPM or anything like that, or especially oil pressure. I don't have an inverted oil system. So let's watch this video, and I'll let it talk. What we're going to do is we're going to do a G loop. I've got a G meter here to reference that sucker. We're going to start it off at 167 knots. We did our clearing turn, and I'm going to pull straight back, okay? I've noticed that I have a tendency, I'm used to doing aerobatics with a stick. This isn't a stick airplane, it's a yoke, so I'm putting bias and a little bit of aileron, so I'm not going to do that. I'm going to hold my hand light and then pull with my right hand on the center yoke. That's going to be my technique. So off we go. Let's get a little dive going. Get to our entry speed. Real quick, there we go. There's 167, so 3 Gs. Pull it straight back. Look out the left. As we get over to the top here, we're going to slack off the G a little bit. Much? Okay. Blew that one. That's a torque roll. It was so slow that the airplane actually torqued a little bit around the prop as the prop continues to spin. You can tell by the engine noise, it really didn't change the engine at all. How about that? It's another view. Watch right here. Started at 167 knots. Goes to 0. Look at the altitude. That's about 7,600 feet. I sliced it off. What I did actually do, besides freezing the flight controls, neutral flight controls, is I just leaned a little bit on the rudder to get that nose to slice a little bit faster. It's looking out the right wing. Out of airspeed, but I have an idea. And then the recovery. I love that choppy noise from the blades. Okay, so that is basically a botched recovery, or for a real extreme, unusual attitude, we just basically neutralize the controls, because if we don't add any aerodynamic inputs, we don't change the engine, RPM, we don't change the ailerons or the elevator or anything like that, rudder or anything like that, the airplane is streamlined, so it won't do something crazy stupid. It may for a short amount of time, but it will sort itself out pretty quickly. And it has the engine, that great big engine, and the nose of the airplane. So the way gravity works is that's going to go first. So it will go downhill with the nose pointing at the ground. I know that, so I have plenty of altitude and things will get better fairly quickly, okay? So what are the lessons learned on this accident? How can it help us? Well, first of all, we have to have I think a proficiency maneuver plan, where you have a plan and you go out and execute it. Is it a dedicated sortie where you do, 4 or 6, 8 different things on a particular sortie, or do you do 1 or 2 on each $100 hamburger leg? Something like that. But some kind of proficiency plan where you can practice your maneuvers. And stalls, I think, are very important in that. You heard my nickel on power on stalls. I don't believe in them. I don't believe in doing them. I do accelerated stalls. I do stalls all day. I like all kinds of different stalls. I like accelerated stalls because I think it teaches you what the airplane does and how to recover from that, versus put you really close into a full departure, setting up for a flat spin. Not my favorite thing. So practice your proficiency maneuvers, expand your personal envelope, okay? What this fella did, I think, was laudable in the fact that he wanted to go out and practice. I guess what I didn't mention earlier was one of the commentators, one of the people interviewed, was a relative, and it said that he went out to practice maneuvers because he didn't fly a lot. He's a relatively new pilot. Went out to practice maneuvers because he was going to do a long cross country with the family. So he wanted to be more proficient. So I'm a huge believer in proficiency, but don't try something new by yourself, okay? I don't believe in teaching yourself stuff. You want to be a test pilot, then okay, you can be a test pilot. Do it under very, very controlled conditions, usually with an IP that knows how to do it and has done it before. So the other thing is be disciplined, fly intentionally. In other words, don't just make it up as you go along. Do everything for a reason. Everything you do in flying for a reason, and that's how we can do that. Keep your energy state in mind, okay? So unfortunately for this fella, he got into a regime where he was not familiar. and didn't know exactly what to do to recover from that. And he was at a low energy state, unlike the probable cause where, okay, it made him sound like he wasn't doing it on purpose. It sounded to me, I think, my theory of this accident is he did it on purpose, but he was not prepared for the subsequent action of what happened after that. So, accidental safety, I don't believe in accidental safety. I think it's on purpose, and safety, in my mind, or my definition of safety in flying is survival, okay? And I think that's a result of attitude meeting reality, okay? Accepting what reality is and then fine-tuning our attitude and our training and our experience levels to deal with that. One of the other things here, and I'll just throw this in, is when you're flying an airplane, wear your pilot hat, no other hat, because if you're wearing your pilot hat, then you're going to make decisions based on what's best in this situation that I'm in and go from there, all right? Surviving by accident can happen. That's accidental safety, and it has happened to people, but it's not something you can plan on. Wishing is not a strategy. So if you have questions or comments, please leave them in the down below in the replies. I'd love to hear that. And for me, it's just it's a forum, and we talk. You guys watch and you make comments, and then I'll reply to that generally, and we can talk about it. I'd like to thank my Patreon supporters here, and without you guys, it would be a little bit harder to do. Thanks for putting up with me. And then if you'd like to subscribe, hit the like and subscribe button. It helps the YouTube algorithm. Okay, dig me out of the hole. Thanks for watching, and we'll see you next time on FlyWire.